Okay, this video is going to be about logarithms or logs. And before we actually get into what they are, I think it helps if we kind of understand why we would need them. So we know things like 2 to the first is 2, and 2 to the third power is 8, because 3 factors of 2, 2 times 2 times 2 is 8. 2 to the fourth is 16, again, because 2 times 2 times 2 times 2 equals 16. But what would you do if I asked you something like 2 to the what power gets me 10? Well, some number will work here. It will, but it's not going to be 3 because that's only 8. And it's not going to be 4 because that's 16. That's too much. So it's got to be somewhere between 3 and 4. The way that we solve this really is we use a logarithm. And a log will just give us the straight answer here, and it basically solves for log base 2 of 10 would give us the number that we would need right here, which ends up being about 3.3. About 3.3. It's not perfect, but it's pretty close. So that's kind of the idea, is like if I don't know what exponent I would need, or let's say you're just dealing with a less familiar exponent, right? Like you didn't know 2 to what number gets me 128. Turns out it's 7, but you could find that by plugging in log base 2 of 128, and that would kick out the answer of 7. Okay, so we're going to talk about logarithms and how logarithms work today. Logarithms are basically, so this is an example of a log equation, and you would read this: log base 2 of 8 equals 3. Log base 2 of 8 is the same as 3. And log equations are very, very similar to exponential equations. We just rewrite basically an exponential equation as a log. It's very similar to like if you have multiplying and dividing or adding and subtracting. In this case, you have an exponent and you have a log. It kind of gives you backwards information. So this right here is what we call exponential form. It's called exponential form because you've got an exponent right here. And this, of course, over here is what we call logarithmic form. Logarithm is like the long version. Everybody just calls them logs, and that's totally an okay thing for you guys to do. An important thing for you to note is that logs are exponents. This thing right here, this whole log base 2 of 8, is the same as 3, and notice 3 is the exponent, so logs are exponents. So let's learn how to write these equations. So this is how you would go about writing a logarithm. This equation right here, 2 to the third power is the same as 8, tells me the same information as what's over here. Log base 2 of 8 is the same as 3. And I really want to stress this. Logs are exponents. Notice this log is the same as 3, which is the exponent over here. So what you are solving for when you do this is you are solving for an exponent. 2, this is the base here, and that's why we also refer to it as a base over here. 8 is what we call the argument. You could think of it as the answer. That's fine. Very few people, I always have to look up that that's called the argument, so don't worry too much about that word. And then the exponent here obviously ends up being the answer. So this is exponential form. This is logarithmic form. These two equations say the same information. So like I said, just like division and multiplication, you have exponential and you have a log form. So over here, this is just like a silly example of that. But again, logs are exponents. So in this case, what I want you to notice is over here we have 2 to the negative 1, 2 to the 0, 2 to the 1, 2 squared, 2 to the third, 2 to the fourth, etc., and what those are equal to. And then over here we have a whole bunch of log equations. I want you to notice a couple of things. One is that the base of the equations, all of these over here, the base is a 2. And every single time I rewrite them here, this is that 2. That log base 2, and this is what we call a subscript. So it's kind of like set a little bit below, just like exponents are up above, logs are a little bit below. So those kind of match up. Then the exponent right here, negative 1, 0, 1, 2, 3, and 4. Notice where those show up over here. They show up on the right side of the equation, where they're equal to the whole log, right? Because I say logs are exponents, like the 4 here is the same as the whole log, right? Equals, you could always say the equal sign. Instead of saying equals, you could say is the same as. And then what this exponential equation is equal to is 1/2 right here. This is what we normally call the argument. And the argument is kind of paired with the log. So the 1 over here shows up right there. The 2 here shows up here, the 4, etc., etc. So you want to get really comfortable with this kind of back and forth of like where the base shows up in the log, where the exponent shows up in the log equation, and then where the argument or the answer of what the exponent is equal to, where that shows up in the log equation. So let's do a couple examples. Here's just another example where we have 3 to the 4th power is the same as 81. That is log base 3 of 81 is equal to 4. We're going to turn these exponential equations into logs. And the way that we're going to do that is, first thing we're just going to look at, and let's just look at this one to begin with, is 4 to the 3rd power, 3 factors of 4 is the same as 64. What we're going to do is we're just going to say, okay, what's the base here? Well, here's where the exponent is. The base happens to be a 4, so this 4 right here is going to end up as the base of my log equation. The next thing in the log equation is what we call the argument, and that is like what this is equal to. So in this case, the 64 is going to go here. And again, since logs are exponents, the exponent is what the whole log is equal to. So maybe pause the video real fast and see if you can figure out what these two would look like, and then I will go through them. So pause, pause, pause. Okie dokie, you have paused. You've definitely done that for sure. You didn't just let it keep going. The 7 is the base. The 5 is the base. The argument is 1 over 49 here. The argument here is 25. And then, of course, the exponent here is what the log is equal to. So in that case, those are all of those things. So hopefully that helps you understand what the logs are. Now, why is not what I even want a log? So let's practice real quick. If I were to rewrite this first log or exponential equation as a log, I would write with a base of 4, an argument of 64, and an exponent of 3. So this would be log base 4 of 64 is the same as 3. Why don't you pause real quick and see if you can work these out yourself, and then I will show you what these are equal to. So you're supposed to pause right now. Are you pausing? Cool, now that you've paused, this has a base of 7, it has an argument of 1 over 49, and it has an answer of 2, that is the exponent. The exponent over here is 2, the base is 5, and the argument is 25. Cool. Well, these kind of questions is really why you'd want a log, is if you were not sure 5 to the what power is equal to 5, a logarithm is how you would solve this. Because you could rewrite this problem, and I know it's kind of unclear because I used 5s and 5s. Poor choices, Perkins. Here's my base. That's that 5. And then this 5 right here is kind of the white 5 sitting there. If you plug this into a calculator, log base 5 of 5, it will kick out the answer of 1. And you're like, oh, of course, I knew that this right here should not just be a question mark, it should be 5 to the 1 is equal to that. Same thing, if you plug this into a calculator, you'd find 5 squared. So instead of question, you'd have 5 squared. You'd have 10 squared is equal to 2. And then harder questions like this, like 4 raised to what power is equal to 2? Well, it turns out that it's actually 4 to the 1/2 is equal to 2. So this would be a 1/2. And it's helpful if you know, because like we can use calculators to do this, but it's helpful if you know how to ask the calculator this. So one of the things I want you to practice today is actually typing this stuff into Desmos. And I'm going to actually make a separate video for how you would do that. But here is at least a screenshot. So you can see I typed in log base 4, and you're going to have to make this what we call a subscript. So it's going to have to go kind of below the log base 4 of 2, and it kicks out the answer of a half. So that would answer my question if I said 4 to the what number, what exponent would give me 2. Or heck, you could even say 4 to the what would give me 34, because I don't know what that number is. But if you plug that into a calculator, you could figure that out. That's kind of the point of logs, is you'd like rewrite this, you'd write log base 4 of 34 is equal to what number? Okay, then as part of our Desmos assignment today, I gave you an example. This is an example ACT problem. And it basically says, if we know this is true, what do you know about x? So log base 7 of 7 to the square root of 7 is equal to x. And the first thing that I would do is I would rewrite this as an exponential equation, where my base is 7, and my exponent is x, and that would be equal to the argument that I have, which in this case happens to be 7 to the square root of 7. This looks so much easier now, because I know that if 7 to the x is the same as 7 to the square root of 7, then x has to be equal to the square root of 7. Okay, I can work that out then. Now I just need to figure out, is the square root of 7 between 0 and 1, between 2 and 3, etc., etc. And my favorite way to do that is to write a number line. So if I have like 0, 1, 2, 3, I happen to know that the square root of 4 is the same thing as 2. So I'm going to write that this is the square root of 4. Square root of 1 is 1, because 1 squared is 1. And I know that the square root of 9 is the same as 3. Okay, well, in that case, I know the square root of 7 is going to be bigger than the square root of 1. It's going to be bigger than the square root of 4, and it's going to be less than the square root of 9. So it's going to be somewhere in here. Somewhere in there, which means that the answer here would be that it is between 2 and 3. So you have a homework assignment. You have 3 choices. You can do just kind of classic practice. You could do a flip grid where you explain something to me, or you could do a more challenging thing. But let me know what questions you have. So here's an example of a question where we might use this. So this says, this is an ACT problem. It says log base 7 of 7 to the square root of 7 is equal to x. And then it says, given this equation is x, and it wants you to find it is between some values. The first thing that I do when I see a log equation, I'm like, dude, I don't know what that is I would rewrite it. And so I'd say, okay, my base is 7, my exponent is x, and that is going to be equal to the argument, which is 7 to the square root of 7. And then you're like, oh, well, that's not so bad. X is the same as the square root of 7. Okay, so x is the square root of 7. And then I just need to figure out what is that between. I love using a number line for this, so now you're having to use some other knowledge that you knew from before, but that's okay. We know that square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. Square root of 9 is 3. Well, since 7 is bigger than 4 and less than 9, the square root of 7 would go somewhere in here, which means that my answer would be B. Hopefully that helps. Try that Desmos activity and then let me know what questions you have.